In this exercise, what we're gonna do is predict the airfoil noise in the seaballs based on a data set which we took from UCI website, University of California, Irvine, machine learning. And the dataset link is provided here with the DOI. DOI stands for Digital Object Identifier, I think. You go to the website and you download the dataset. Okay. As for the features, we see a table that has 6 columns, 6 fields. 5 of them, of course, are features, and the 6th is the target. So what we're trying to predict is the scaled sound pressure in the seaballs by relying on different parameters such as the frequency in hertz. I believe it is the frequency of the air, the vibrational frequency of the air against the wing, the attack angle of the air direction against the wing, chord length, which is the distance from the leading edge to the trailing edge, free stream velocity, and suction side displacement thickness. To make it more clear what we're talking about, this is a display of the different parameters we are referring to. So the chord length is the distance from the first tip of the wing to the end of the wing, to the last tip. This is called leading edge. This is called trailing edge. Of course, this is a wing section, what you see in this picture. Then the attack angle, which is the angle between the direction of the wind, let's say this is the wind direction, and the chord length. This is the attack angle, okay? Of course, it is a virtual direction. A direction or a line, a virtual line between the leading edge and the trailing edge. After that, what other parameters do we have? The suction side thickness. Okay, suction side thickness, which is the thickness of the air around the wing from the top to the bottom, if I'm not mistaken, and the free stream air velocity, or the velocity of the air streaming around the upper camber or the lower camber. Practice part. So we are in Google Colab. What we're gonna do is import the project, the dataset rather. I have the link above for where we've gotten the dataset from. We're gonna upload it to Google Colab. Actually, it is from University of California, Irvine. So we're uploading. It has multiple fields, of course, the last one being the target. At first, we're importing pandas to be able to read that file, which is not a CSV file, by the way. We are designating the columns that are the field names because they didn't come inherently with the dataset. I've gotten them from the website where we've downloaded the dataset. Frequency, attack angle, chord length, free stream velocity, SS displacement, displacement thickness, or the thickness of the layer of the air from the upper to the lower camber around the edges of the airfoil. Finally, sound pressure expressed in the seaballs. Now we're gonna read the dat file. The separator is not a comma, it's actually a tab. So airfoil dot dat underscore noise, of course, separator equal backward slash T for tab, and names equal calls. We are attaching the names of the fields or the columns. df.head, and these are the different fields with their respective values. Okay, so we're going to try to find a relationship between different features and the target value. Let's import matplotlib.pyplot as PLT. to see the histogram for different values. Bins equal 30, figure size equal, let's make it 15, yeah, 10. plt.show. Okay, and we see the relationship between different features and the main target, which is the sound pressure. So for minimal angle you have a high sound pressure. For the chord lens, you see, okay, it is, you have multiple, you know, it's distributed. The angle of attack, for lower angles you also have higher pressure, etc. Okay, let us import from sklearn.preprocessing the standard scaler to scale between different values to normalize these values, okay, so that you won't have a big gap between a small and a large value, so that we can quantize these values for machine learning. Then we're gonna import linear regression. It will be the model chosen for this example. From sklearn.model selection, import train test split to split data into train and test. Okay, from sklearn metrics, import mean square root and R2 to measure the accuracy and the loss within this model. Okay, so x equal df.columns -1, meaning get me all the columns except the last one, which is the target. Y equal df, here get me the field which is sound pressure, so it would be the last field, as you will see, okay, which is the target, which is the values we're gonna train on one hand and then predict on the other hand. We're declaring a standard scalar, x equal scalar dot fit transform df of x, large X. X train, X test, Y train, Y test equal train test split. We're splitting the data set into 70%, actually 80% for training and 20% for testing. This is the testing slot is 0.2, which is 20%. This is what it actually means. And random stain to shuffle the data set, to shuffle the data so that we won't have a sequential collection of data. That's why. So we split the data into train and test. We train the data by the 80%, then the 20% we're gonna test if the model works. So model equal linear regression, model.fit, x train, y train, y prediction equal model.predict, x test. Print y prediction. Oh, we have an error. Oh, actually, yeah. X train, X test need to be capitalized. Okay, so these are the different values for the prediction. Okay, we have predicted the test portion. Thus, we can measure the mean square error and the R2, which gives us the accuracy of the model. Mean square error, the accuracy of the model. MSE equal mean square error, y test, y pred, R2 gives us how much accurate the model is. In other words, the gap between the predicted value and the actual value. Okay, this is the metric. X test, Y test, and let us print both values. Let's tab them together. Okay, great. Run. So the accuracy is 55.8%. It's not very good, but it's okay in our example here because we wanted to use the linear regression model. That's why. So 55.8, around 56% accuracy. Let's try to predict a sample. Let's create a sample and try to predict it. Okay, we're gonna take that sample from the original data, data set. Okay, but we're gonna tweak the values to change them so that we won't have a value that has already been tested or trained. Okay, to try to predict a new value, a new portion, a new sample. Okay, that does not exist within the original data. So example equal 1000. Okay, these are respectively the 5 features. Let's split them. Yeah, and I've changed the values. I pasted them from somewhere else. Y new prediction equal model dot predict x sample. We're surrounding it by square brackets because it's not an NP array. We need to change it into a format of NP array. I'm formatting the string right now. Ypred decibels, which is the value. Okay, great, very good. Okay, this is the predicted value. However, you see what happened? The value does not make any sense. So I needed to scale this sample as well so that you would get a logical value. Okay, this is the problem here because the value we've gotten was minus 0 point something. It's not an actual value. So we've changed it, we scaled it, using scalar.transform, and we've gotten the correct logical value 116 decibels.